Students, myself Ms.Wale, I am from Shri Siddheshwar Women's Polytechnic, working as a lecturer in Electronics and Telecommunication Engineering Department. I am the in charge of Analog Electronics Lab. Now, today is for the second year students for third semester under the subject of Applied Electronics. This is your first experiment, that is a single stage common emitter amplifier. This is your simple basic circuit diagram. These are the required components: resistor, transistor, capacitor, one function generator and CRO. And the procedure is as followed. This is your observation table and you get a frequency response. Today's your first practical is a single stage common emitter amplifier. Okay. This is your simple circuit diagram. In that we required 4 resistors. That is this one resistor R1, R2, RE, and this is your collector resistor RC. Okay. R1, R2 and RE are used to bias the transistor in active region. We also require 2 capacitors, that is the capacitor C1 and C2. These are the coupling capacitors and this capacitor is a bypass capacitor. Okay. Now we see how our amplifier amplifies the signals. For that we required a input signal. This is a small signal amplifier, that's why we give a input signal from our function generator. This is a function generator. By using this function generator, we can first set our input which is to be applied to the amplifier input. For that, first connect this CRO's output terminal to the function generator's output terminal to the CRO. Here we get a sine wave. Then here press a attenuation button on 40 dB. Okay. Now here set your frequency as 1K. This is our 1K frequency. Here set our input in a millivolt. Okay, here one block multiplied by 20 millivolts means our input is 20 millivolts. This here we set the input. Now connect this input to our circuit diagram. Here is our input. So this red is connected to the base of the transistor and this black is to the ground. Now to observe the waveforms, we required to connect our output to the CRO. Here, connect this red one and here black. Now see on CRO, here we get the amplified signals. See here, now we get a output is, yes, measure the blocks, 1, 2, approximately 3. 3 multiplied by 50 millivolts means we get 150 millivolts as the output. That means when we apply a 20 millivolt as the input, we get an amplified signal, that is a 150 millivolts as the output. Now here we get 20 millivolt as the input and we get now 150 millivolt as the output. Means your small signals are get magnified or its amplitude gets increased. If you want to see your input waveforms on CRO, then connect another one probe to the input side and on CRO press dwell. Okay. Now this is your output waveform and this is your input waveform. Already we have studied that in amplifier we get a 180 degree phase shift in between the input and output. See here, this is your output waveform and this is your input waveform. In between the output and input we get a 180 degree phase shift. Okay, and this is our observation table. In that, this is your input frequency and we measure the output voltage. When we increase the frequency, we can observe the output voltage waveform on CRO. At low frequency, your output voltage gets on increasing. In mid frequency, you get a constant output voltage, and at high frequency, your output voltage goes on decreasing. Okay, now as per our observation table, we can change the input frequency and observe the waveforms on CRO. First, at low frequency, see here, your amplitude goes on increasing. As we continuously increase the frequency, you get a increasing amplitude. This is our low frequency signals. If we increase frequency, here our amplitude goes on increasing. Okay, from low frequency to up to where we get a constant output voltage. Now I said 1K. See there, at 1K, after the 1K, if I increase the frequency, you get a constant output voltage. See. There is no any change in the amplitude. Okay, now at high frequency, from above 100 kilohertz, see here, now this is a 10 kilohertz frequency. If I continuously increase, you get a constant output voltage. But after the 100K, it goes on decreasing. See. Okay. Now we conclude that at low frequency, your voltage increases. At mid frequency, voltage is constant, and at high frequency, it goes on decreasing. Now, bandwidth is nothing but the difference between higher cutoff frequency minus lower cutoff frequency. Now, plot the graph. On x-axis frequency and on y-axis there is a gain. Thank you. We can also measure our output voltage by pressing this XY mode and see how it becomes decreases. See, if I change the frequency, your amplitude goes on decreasing. If increase, it goes on increasing.